In today's class, we'll discuss class 10, chapter 12, electricity, question number 13. The question is a hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. And what are the currents in the three cases? There are three cases. The first case is the two coils can be used separately and you have to find out what is the current for the case. And second case is when the two coils are connected in series, and the third case is when the two coils are connected in parallel. So case 1. When two coils are used separately. So given potential given 220 volt on resistance, that is given 24 ohm, and you have to find out the current for this case. So you have to use Ohm's law. By using Ohm's law, V, that is equals to IR, potential difference, that is equals to current into the resistance. So here you have to find out the current. So current I will be V divided by R, and V, the potential difference, is given 220 and the resistance is given 24. And when you divide 220 with 24, you find the answer 9.16 ampere, and that is nearly equals to 9.2 ampere. So for the first case you find the current, that is 9.2 ampere. And case 2. Case 2 is when the two coils are connected in series. Two coils are connected in series, and for series connection, first you have to find out what is the net resistance in series. So the formula to find out the net resistance in series, that is RS, that is R1 plus R2, where R1 is the resistance of the first coil and R2 is the resistance of the second coil, and here the resistance of each coil are equal, and that is 24 ohm. So this is 24 plus 24, that is 48 ohm, and you have to find out the current again by applying Ohm's law. V is equals to IR, and here current I will be equals to V divided by R, and here potential is given 220 and the resistance in series is 38, and when you divide 220 with 48, the answer will come 4.58, or that is nearly equals to 4.6 ampere. So here for series connection you find the current 4.6 ampere. And third case, when the two coils are connected in parallel. two coils are connected in parallel. So here you have to find out what is the net resistance when the two coils are connected in parallel, and the formula is 1 divided by Rp, that is equals to 1 divided by R1 plus 1 divided by R2, and here resistance of each coil are equal, so you can write that is 1 divided by 24 plus 1 divided by 24, so that is 2 divided by 24. That implies Rp will be 24 divided by 2, that is 12 ohm, and you have to find out what is the current in this case. So to find out the current you have to use Ohm's law. By using Ohm's law, V is equals to IR. Again you have to require to find out the value of current, so that implies I will be V divided by R, and here the potential is given 220, and you find the net resistance in parallel connection is 12, and when you divide 220 with 12 you find 18.33, that is nearly equals to 18.3 ampere. So you find the current for parallel connection I is equals to 18.3 ampere. So these three are the required answer. So when the two coils are used separately, you find the current I, that is 9.2 ampere, and when the two coils are connected in series, you find the current, that is 4.6 ampere. And third case, when the two coils are connected in parallel, for that case you find the current I, that is 18.3 ampere. Thank you.